Okay, binocular rivalry and continuous flash suppression, potent tools for the search of the NCC. Binocular rivalry and continuous flash suppressions are highly potent tools to identify the NCC. They can be used to exclude some brain areas from the MCC candidates. That's the sort of use of these techniques. So binocular rivalry as a potent tool for the MCC search. As we reviewed in last week, this new separation of the neural correlates of sensation, sensory input, neural correlates of the consciousness, and neural correlates of the behavioral output are critical to the identification of the NCC. And for that, one of the most dominant or useful paradigm is this subjective experience itself changes while stimulation and or remains constant. And that's the situation of the neural correlates of the binocular rivalry. The binocular rivalry can be induced by many ways, but the key here is that the right eye and the left eye receives the input, slightly different input. So here, using a green and red filter, you can see a house in one eye and then face in the other eye. Or using this type of the expensive mirrors, you can also see this vertical grating with the left eye and the horizontal grating on the right eye. Or you can use a cheaper kind of trick of prism to see on the vertical or left right eye horizontal gratings. You can do many things to achieve the binocular rivalry. And you don't even need any kind of equipment, in fact. So if you place your finger like this, and then to look at the screen in front of you or up, behind this finger, and then wait for a couple of seconds, and then you'll see that the fingers starts to generate some kind of binocular rivalry, right? And now I'm seeing that at the center of my vision, there is one floating sausage-like fingers are happening, but now it's actually connecting to left eye, but now right fingers. And then after a while, I now see that everything starts to get connected. So it's just one finger from left to right and so on. So this kind of thing can be tried by yourself in front of the white screen or black screen. That's probably easy to see. Another easy way to induce binocular rivalry is to use the paper. So here, if you roll up the paper like this, and then hold this with your left hand, like this way, here, around here. And then see through the right eye. And then you open both of the eyes, okay? Right eye and the left eye has to be open both at the same time. And then by manipulating the diameter of this hole and also the distance to the hole, you can probably induce situation where you see a big hole in your hand. Like this way, yeah. And again, because this is a part of the binocular rivalry, after you wait for a couple of seconds, then the hole gets sort of fixed and then closed, or then after a while it starts to become open and so on. Here, this is again the illusion, binocular rivalry percept induced by binocular conflict of the binocular rivalry. Okay, and then finally, you can also induce something like this if you go in front of the mirror and then try to close your eyes or polarize your eyes. And the key here is that to align your left eye and the right eye at the same location. And then you probably see in the mirror like something like this. And then if you wait for a while, then you will see that only your left side of the face becomes dominant, and you see only one face or the other face. But then sometimes you start to see only one-eyed cyclops-like face of yourself, or a three-eyed kind of face. That's what we termed as a third eye rivalry. But you can also experience this in front of the mirror. Okay. And the important thing about the binocular rivalry in any kind of variant is that the dominance duration of one percept, let's say if it's a finger or hole or your face, it tends to form some kind of distribution like this. It's called the gamma distribution or log normal distribution. If your duration is let's say if your duration of the dominance tends to peak at, let's say, 3 seconds or so, then practically it is impossible to predict whether the next duration is going to be either longer, like let's say 10 seconds, or shorter, like only 1 second. It's quite stochastic. There are some claims that are made that maybe, measuring a pupil dilation and so on, you can make a prediction about that, but that's a bit controversial. And another thing that is also critical for this binocular rivalry is that there is some kind of, counterintuitive properties. So for example, let's say if the left eye and the right eye are receiving these horizontal or vertical grating, and then you measure the mean dominance duration. So this is a peak or median of these things for, let's say, left eye. Okay, and then even when you make the strength of this left eye stimulus, so here the horizontal grating becomes stronger and stronger and stronger, then the duration of the dominance stays more or less the same. So the stronger stimulus does not necessarily result in the longer duration of the dominance. On the other hand, if you fix the strength of the left hemisphere, left eye input, while changing your right eye stimulus, okay? And then when the right eye stimulus is very strong here, then left eye stimulus is perceived only like 4 seconds. But if you weaken this into 0.2 and so on, then the other side, this left side stimulus starts to become longer and longer to be perceived. Okay, so it's something that you discover only when you yourself try this kind of manipulation, but it's rather difficult to predict that this is going to happen, right? But that's a very critical kind of useful property of the binocular rivalry, as I explain next. And then finally, we also have this continuous flash suppression that I discovered while I was a graduate student. So here, instead of presenting 2 stationary stimulus, you can present pretty much any kind of a stimulus to one eye, and then the other eye should receive some kind of a random, non-repeating, and flashing kind of stimulus. And then it dominates the percept quite a long time. And unlike binocular rivalry, we can set the stimulus percept relatively stable and predictably. And this can be used not only to perceive, moderate the conscious percept from seeing this one initially to overcome eventually by the face, but to see whether completely invisible stimulus can elicit any kind of behavior as well. So the key here is that edge-rich changing 10 Hertz Mondrian patterns. Mondrian is a painter in the Dutch painter, and they liked he liked paintings like this. And then this kind of patterns can reliably suppress the visual input to the other eye for long duration. So that's called continuous flash suppression. All right. So together with Binocular Rivalry, CFS also are potent tools for studies of non-conscious processing. In summary, Binocular Rivalry can be induced in everyday life using finger or paper or in front of the mirror. And under constant sensory stimulation, conscious percepts can flip between two alternatives in a random manner. And in fact, it's more than two alternatives, as we might discuss in the later time. And CFS can suppress a stimulus more reliably than the Binocular Rivalry. Okay, so now the critical question for us is that how do the neurons respond during the Binocular Rivalry? And that's what we are going to look at in the next two videos.